Here are the examples for the Venn diagrams I want you to look at so you can understand how this works. It's a logical process. We're going to draw out the premises and then see if you can read the conclusion from what's been plotted. So in this case, this particular argument says all humans are mortal. Socrates is a human, Socrates is immortal. So we have two different classes of things being discussed. The class of humans, the class of mortals. So we have a circle representing each class, the human class, the mortal class. Socrates is a particular case, and I'll show you how to plot that, but for right now we need to make sure we get the two qualities or classes differentiated here. So each circle overlaps and allows us to diagnose how they relate to each other. So in this case, what I want you to do for plotting any universal statement that says all humans are mortal, that's going to basically remove anything that's not human and mortal. So we have human, we have mortal, and this area overlapped is human and mortal. So when we say all humans are mortal, there is nothing that is human that is not mortal. So we need to eliminate this section of the human class from consideration. So I want you to click on the paint can over here, pick a color that's sort of, not too garish, and eliminate that from consideration, right? So now all we're left with are, whoops, don't do that, human things that are also mortal. Right? Now Socrates is a human, so what I want you to do is click on the text box, make sure you click back on the text color, otherwise it's going to come out pale yellow again. You draw a little text box here, and we'll plot S for Socrates. When you click outside of the box, it'll close it out. So now we have S is a human. Socrates is a human. If you look down in the symbolism, it's all H's are M's. So anything that's an H is also an M. S, Socrates, is an H. The only area left, we can't put S over here because it's been eliminated from consideration, so we have to put S here. So Socrates is human, and then we try and read the conclusion from this. Socrates is mortal. If we go to where we wrote the S for Socrates, S, also lies within the realm of mortal things. So Socrates is both human and mortal, and so therefore this is a valid argument. So again, with the text box, just drag a square and just type in valid. That's really all you need to do for the valid diagrams. If you're interested, there is a different way of doing the symbolism here. This is described in your textbook as well, towards the end of the Venn diagram section. The predicate calculus has a different way of describing the same kind of relationships we're talking about here. It's more sophisticated over here, but I'll stick with this one, I guess. For all things, that's what the X is, it's a universal quantifier. For all things, if it is an H, then it is an M. If it's human, any human, X, it's also a mortal, X. Any mortal is what the MX stands for. Right? And so that's basically what all H's are M's means. And then for the individual, Socrates is a human, an H. It looks this way, HS. And then you draw the conclusion, Socrates is a mortal, it'd be mortal, and Socrates is the particular instance of mortality. So if you are interested in trying to write things out this way, more power to you. It's another way of doing it. It leads to some more complex logic. You certainly aren't required to know that at this point. This form of symbolism right here is the standard one at this point in your logic career. So the second example is going to be another two-circle Venn diagram. And this one is going to be intuitively wrong. You're going to be able to tell that it's not right, but the Venn diagram allows you the diagnostic tools to figure out how. All dogs are mammals. My girlfriend is a mammal. Therefore, my girlfriend is a dog. Right? This is clearly wrong. And so the Venn diagram allows you to diagram it to figure out why it's wrong. Okay, so again, we click on the paint can over here, pick a color. All D's are M's. All dogs are mammals. So if it's a dog, it also must be a mammal. So here's the area where dog and mammal overlap. So all dogs have to be in this area. There is no such thing as a dog that is not a mammal, so you eliminate that from consideration. it's like crossing it out. You shade it in and say that's no longer part of the consideration in this argument. Second premise says my girlfriend is a mammal. That's a particular one girlfriend out of all possible mammals. So I'm going to draw a text box and say my girlfriend is a mammal. Now there are two zones here in the M region, right? G is an M. There are two possible places where we can put G. So we have to place it in both. We'll put a G here. Again, making sure you change your text color. And then we'll also put a G here. And then we move on to the premise. So I'm sorry, to the conclusion. We've diagrammed both premises. Now we'll do the conclusion. Try and read the conclusion from what we've charted out here. My girlfriend is a dog. So look at where G is, and it will show you pretty clearly that G could be in two different places. It could be that my girlfriend is a dog. It could be that my girlfriend is a mammal and not a dog, but we can't tell by looking at the diagram. It's ambiguous. It's sort of inconclusive. So what I want you to do in this case is draw another text box and type in an explanation about this thing. It's invalid, and then explain why it's invalid. Briefly, it's an ambiguous location of the particular. And then you click outside of the box, that'll close it out, and then what you've done is identify the ambiguity within this argument that makes it invalid. So I'm going to close this out right now and then open up a second tutorial for the other two 3-circle Venn diagrams.